right, let's dive into this new research paper from Google DeepMind
Okay.
called Matryoshka Quantization.
Sounds kind of intimidating, huh?
It is sound a little intimidating, but it's got some pretty fascinating implications, I think.
Yeah, it's a really cool paper.
So, for our listeners who maybe haven't heard of Matryoshka Quantization before,
Yeah,
can you give us like a high-level overview of what problem this research is trying to solve?
sure. So, like we all know, AI models, especially large language models, are becoming more and more powerful.
Right.
But they're also really resource intensive,
Yeah.
especially during what's called the decoding process, which is basically like using the model, to generate text or to translate languages or whatever it is you're doing with it.
Okay, it's not just about the size of the model itself,
Right.
but it's also the amount of computing power it takes to actually use the thing.
Exactly. It's like, you could have the most powerful engine in the world, but if you don't have enough fuel, it's not going to get you very far.
Right, right.
So what these researchers are trying to do is figure out how to make these AI models smaller and faster without losing any of their smarts, so to speak.
Okay, that makes sense. So how do they propose to do that? What's this Matryoshka quantization all about?
Well, the idea is actually pretty clever. It's based on this concept called quantization, which basically means shrinking those bulky floating point numbers that computers use
Yeah.
down to smaller integers, kind of like compressing a file, to make it take up less space.
Okay, I get that. But doesn't that make the model less accurate? Like you're losing information when you compress a file?
That's the traditional trade-off with quantization. You gain efficiency, but you often sacrifice some accuracy, especially when you go to really small integers like int2.
So it's like choosing between a really smart but slow model.
Right.
Or a fast but kind of dumb one.
Yeah, that's a good way to put it. And often, researchers would have to create multiple versions of the same model
Oh, I see.
for different needs, which is obviously inefficient.
Right. So where does this Matryoshka thing come in?
So Matryoshka Quantization, or MatQuant for short, takes a different approach. They actually train a single model that can operate at multiple levels of efficiency, kind of like those Russian nesting dolls,
Oh, okay. Yeah, I see where you're going with this.
So you have one model that can work at int8 precision, but then inside that is another model that works at int4, and then another one at int2, and they're all kind of nested within each other, sharing some of the same information.
So it's like a model with multiple personalities.
Yeah, exactly. And here's the mind-blowing part. The int2 model, the smallest and most efficient one, is actually more accurate than a standard int2 model that's trained separately.
Wait, hold on. It's smaller, faster, and more accurate. How is that even possible?
Well, the key is in how these models are nested. They share the same most significant bits, which allows the lower precision models to benefit from the knowledge of the higher precision one.
That's really clever. So it's not just about shrinking the numbers, but also optimizing how those numbers are used across the different levels of the model.
Exactly. It's like having this master chef who trains a whole team of cooks, and they all learn from each other, even if they're using different tools and techniques.
Okay, I'm starting to see why this is a big deal. But you mentioned earlier that this MatQuant thing works with existing training methods like QAT and OmniQuant.
Right.
What are those, and why is that important?
So QAT and OmniQuant, those are popular techniques for training quantized models, but they usually focus on just one precision level at a time.
Gotcha.
What's cool about MatQuant is that it works as an add-on to these methods. So it's not like you have to completely reinvent the wheel.
Okay.
You can just integrate MatQuant into your existing training pipeline, and boom, you've got this multi-level precision capability.
So it's like taking something that's already good and making it even better.
Exactly. And by optimizing the model weights for all those precision levels simultaneously, they all kind of learn from each other,
Oh, interesting.
which leads to some pretty remarkable results.
Okay, this nesting doll analogy is really starting to make sense to me now. But does that mean we're limited to just int8, int4, and int2? What if you need something in between?
That's where things get even more interesting. With MatQuant, you can actually get these in-between precisions, like int3 or int6, just by kind of slicing the int8 model.
Slicing, what do you mean?
So imagine the int8 model is like a loaf of bread, and you can just cut off a slice to get the int6 model, or another slice for int3, and so on.
Oh, wow. So you're not actually training new models. You're
Yeah.
just sort of extracting them from the existing one.
Exactly. It's like getting bonus models for free, which is pretty awesome when you think about it.
That's incredible. So much flexibility built into a single model.
Right, and the flexibility doesn't stop there. They also came up with this concept called mix and max, which allows you to use different precision levels for different parts of the model.
Wait, so like one part of the model could be running at high precision for something that needs it,
Exactly.
while another part is running super efficiently at a lower precision?
You got it. It's like having a Swiss Army knife of an AI model. You can customize it for whatever task you need.
This is blowing my mind. Okay, before we get too far ahead of ourselves, tell me more about this single precision MatQuant thing you mentioned earlier.
Yes. So that's the variation of MatQuant where they said, hey, what if we only care about getting the best possible into performance? Like we want the smallest, most efficient model we can get, accuracy be damned.
Okay, and what happened?
Well, they were able to push the accuracy of that int2 model even further, which is pretty amazing considering how small and efficient it is.
So it's like they squeezed every last drop of performance out of those tiny little int2 numbers.
Exactly. It just shows how much potential there is in this MatQuant approach and how flexible it is.
Okay, I'm starting to see why you were so excited about this research. This MatQuant really does seem like it could be a game changer for AI accessibility.
It really does. Imagine a world where anyone, anywhere, can access cutting-edge AI, regardless of their computing power. That's the kind of future this technology could enable.
Okay, now we're talking. But before we get too carried away with all the possibilities, there's one more thing I'm curious about. You mentioned that MatQuant helps stabilize training when you're quantizing both the FFN and attention parameters in these models.
Right?
What's so tricky about that?
Well, FFN and attention, those are two really important parts of these large language models, but they're notoriously difficult to quantize at low precisions, like N2. The training process can become really unstable, like trying to balance a house of cards on a windy day.
Oh, I see.
But MatQuant, with its unique approach, seems to provide a solution. It stabilizes that training process and unlocks even more efficiency gains.
Wow, I'm officially impressed. This Matryoshka quantization really seems to be pushing the boundaries of what's possible in AI.
And we're just scratching the surface. There's so much more to explore with this research. In fact, the researchers even hint at the possibility of extending MatQuant to floating point numbers.
Whoa, now that would be a whole other level of groundbreaking.
It would. But we'll save that discussion for later. For now, let's dig a little deeper into the implications of MatQuant as it stands and why this could be such a big deal for the future of AI.
All right, you got me hooked. Let's do it. So we've talked a lot about how Matryoshka quantization can make AI models more efficient.
Yeah.
But I'm kind of curious, what does that actually look like in the real world? Like, who benefits the most from this kind of technology?
That's a great question. It's not just about making things faster. It's about making AI accessible to everyone.
You mean like people who don't have access to these massive data centers and supercomputers?
Exactly. Researchers in developing countries, students, educators with limited budgets,
Yeah.
even just everyday people who don't have the latest smartphone.
Right.
MatQuant could make it possible for them to use these powerful AI tools without needing a ton of computing power.
So it's about democratizing access to AI, not just making it faster.
That's a great way to put it. It levels the playing field and allows more people to benefit from AI regardless of their resources.
That's pretty powerful stuff, and it sounds like it could have a huge impact on so many fields like education, healthcare, anything that relies on data.
Absolutely. And don't forget about the environmental impact.
Oh, right.
Training and running these huge AI models uses a lot of energy.
Yeah.
So anything that can make them more efficient is also good for the environment.
So it's not just about access and speed, it's about sustainability too.
Right. Less energy consumption, smaller carbon footprint for AI. It's a win-win.
This is really making me rethink the whole AI conversation. It's not just about building bigger models, but about finding smarter, more sustainable ways to use them.
You got it. And speaking of smarter approaches, the paper also talks about something called hardware-software co-design.
Okay, now you're losing me a bit. What does that mean?
So traditionally, hardware and software have been developed separately.
Right.
But with MatQuant, we can start thinking about designing them together, specifically for these efficient AI models.
So we're not just optimizing the models themselves, but also the hardware they run on.
Exactly. And this co-design approach could lead to even bigger gains in efficiency. Like, remember that mix and match concept?
Yeah, where different parts of the model can run at different precisions.
Well, imagine hardware that can adapt on the fly to support those different precision levels. That's what co-design could enable.
Wow, that's pretty next level stuff. So we're talking about AI models that can adapt to their environment, becoming even more intelligent and efficient over time.
That's the idea. And this hardware-software co-design, it's not just some futuristic fantasy. It has real-world implications right now.
Okay, give me some examples. How could this change the way we develop new AI applications?
Well, for one thing, it could make it much easier and cheaper to work with large language models.
So you're saying you wouldn't need a Google-sized data center to start developing cool AI applications?
Exactly. This could empower smaller companies, startups, even independent researchers to work with these powerful AI tools.
That's exciting. It's like opening up the AI playground to everyone.
And it could also significantly improve existing applications.
Like what?
Imagine chatbots that are even faster and more responsive, voice assistants that can handle more complex tasks, even on low-power devices,
Oh, I see, yeah.
or even personalized AI experiences that adapt to your individual needs and preferences.
Okay, now you're talking. Personalized AI, that's a whole other rabbit hole.
Right.
But it also raises some ethical questions, doesn't it? Like, how do we ensure that this kind of technology is used responsibly?
You're absolutely right. As AI becomes more powerful, we need to have serious conversations about ethics, about bias, about privacy.
Yeah, for sure.
These are questions that we need to be thinking about as AI continues to evolve.
It's a lot to consider. AI has so much potential for good,
It does.
but we also need to be aware of the potential risks.
I completely agree.
In a way, I feel like MatQuant is pushing us towards those conversations.
How so?
By making AI more accessible and efficient,
Yeah.
it's kind of accelerating the pace of development, which means we need to be thinking about these ethical issues sooner rather than later.
That's a really good point. It's like we're at a crossroads in AI development.
Right.
And MatQuant is pointing us towards a future where AI is more efficient, more inclusive, and more personalized.
It's exciting, but also a little bit scary.
Yeah, I know what you mean.
It's a future that we're all shaping together, and we need to be mindful of the choices we make.
Absolutely. Every decision we make, every line of code we write
Yeah.
is shaping the future of AI.
I'm really curious to see where this all goes. But before we wrap up, there's one last thing I wanted to ask you about.
Yeah.
You mentioned earlier that the researchers talked about extending MatQuant to floating point numbers.
Right?
Honestly, I have no idea what that would even look like.
I know. It's a mind-bending concept.
What kind of impact could that have?
Well, that's a question for the ages, isn't it?
Yeah.
It could have implications far beyond AI, potentially revolutionizing the very foundations of computing as we know it.
All right, my brain is officially fried trying to imagine Matryoshka quantization for floating point numbers.
Yeah, it's a pretty wild concept.
It sounds like something straight out of, I don't know, Star Trek or something.
It kind of does, doesn't it? But it shows how fast this field is moving. A few years ago, we were struggling to even run these massive AI models.
Right.
And now we're talking about fundamentally changing how computers represent numbers.
I'm still trying to wrap my head around what that would even look like.
Mm-hmm.
I mean, floating point numbers are like the foundation of computing, right?
Yeah, they're how computers deal with all those decimals and fractions and things. It's how they
Yeah.
do all those complex calculations, simulations.
Right.
But even floating point numbers have limitations.
Okay, so you're saying that MatQuant could make even floating point numbers more efficient.
That's the crazy idea. Imagine applying this whole nesting concept
Yeah.
to the very way computers represent numbers.
Okay, but my brain is hurting just thinking about it. What would that actually do? Like, what kind of impact would it have on, the stuff we use every day?
Well, think about scientific simulations that could run way faster.
Okay.
Data analysis that's more powerful, video games with crazy realistic graphics.
Wow.
We're talking about potentially changing the whole landscape of computing.
Okay, now I'm starting to get the bigger picture here.
Yeah.
It's not just about AI anymore. It's about, upgrading the very foundation of how computers work, making them faster, more efficient, and capable of doing things we can't even imagine right now.
Exactly. And it all comes back to this idea of nesting models, finding smarter ways to use the resources we have.
It's like those researchers at DeepMind said, hey, what if we could squeeze more performance out of every single bit?
Right, they weren't satisfied with just making AI models more efficient.
Yeah.
They wanted to rethink the whole system.
It makes you wonder what other areas could benefit from this Matryoshka approach.
Right, we've been talking about computing, but what about other fields?
I know, it's such a simple but powerful idea, these nesting dolls.
It is, isn't it?
Could we apply this to biology? Imagine nested models of, biological systems, from cells to entire ecosystems.
Or economics. Nested models of financial markets or global trade networks.
This whole deep dive has really made me realize how much potential there is in just taking a step back
Yeah.
and looking at things from a different perspective.
That's what Matryoshka quantization is all about, isn't it? It's not just a technical thing.
Mm-hmm.
It's a new way of thinking about efficiency and problem solving.
It's like those researchers were looking at these Russian nesting dolls and had this ha moment.
I love that.
This whole conversation has been full of ha moments for me.
Me too.
We started with this research paper,
Yeah.
and now we're talking about the future of computing and beyond.
It's amazing where a single idea can take you, isn't it?
And that's what the deep dive is all about, right? Taking a complex topic,
Mm-hmm.
breaking it down, making it fun and engaging, and hopefully inspiring some ha moments for our listeners.
Exactly. We want to empower you with knowledge.
Yeah.
And get you thinking about the world in new ways.
So the next time you come across something that seems complicated or confusing, remember Matryoshka quantization?
Remember those nesting dolls?
There's always another layer to uncover, another perspective to explore, another aha moment waiting to be discovered.
Keep exploring, keep asking questions, and keep diving deep.
Thanks for joining us on this deep dive, and until next time, stay curious.